Okay.
Okay. So if you're filming, it's not gonna make a difference. I won't see, but I can still hear you. All right, so I kind of changed the questions a little bit, but basically the same thing. I just changed some values around. Just to recap real quick first. This is kind of the same thing that's already in your old videos, but this section we have two formulas. They're the same formula basically, solve for different letters again. So this one is the present value of an annuity. A little confusing the wording here because annuity we used in the previous section to mean something else, right? But the difference is this is the present value. So present value meaning in this instance, what is the value of an amortized loan? So how much are you going to borrow, in other words? That's assuming you know how much you can pay per month. You know the M value. Okay, so we have two formulas, like I said, the same except for different variables. First formula tells you how big a loan you could take if you know the monthly payment you can make, the interest rate, length of time over which the loan will be paid. These are typically called amortized loans, and they're used for houses and for cars mainly, or for other large loans. So if you actually, if you buy a car and you finance it, that's typically what will happen. Or if you buy a house, you pull out a mortgage. That mortgage is just a word for the type of amortized loan that we're talking about. Second formula, like I said, is just this first one, solve for M instead. So if you know the loan amount, you want to know how much you're going to pay per month. When I say month, this could also be like every year or every quarter, depending, but standard value is once per month. So we just assume month unless we're told otherwise. Okay, both formulas, M is the periodic payment, P is the loan amount, R is the rate, T is time in years, and N is the number of payments in 1 year. So N is kind of similar to the number of compounds in a year, or if you think back to the old annuity formula, the number of compounds is the same as the number of times that you paid in 1 year, right? So that kind of is basically the same. Basically, the only new thing is actually there's not really anything new because we've seen M before for the periodic payments, right? P is basically like the principal, how much you're borrowing, the starting loan amount, and so yeah, that's pretty much it. Okay, so number one, I just changed things slightly. Let's say you can make $150 monthly payments, and the rate is 0.7% instead. I changed this because someone had a question about fractional percentages. So just a small percentage, 5 years, and then what is the present value? Okay, so that means we're using the present value formula, right? The P one. Remember, exponents always in parentheses, negative NT, close it, and then numerator in a set of parentheses, denominator in a set of parentheses to be safe. Now the Desmos one, it actually, you can get away with not having the parentheses just because it sort of intuitively understands what you mean, but in a normal calculator, you need the bottom ones for sure. Okay, so let's type in our question. What I like to do typically is just list out my variables that I know. And the big thing for this section is figuring out which of the two formulas you're going to use. But the obvious way to tell is just look for what are you given. If you're given that thing, then of course you're not going to solve for it, right? So if you look at question number one, you're given M. So I clearly don't want to use the formula that solves for M because I already have M. Yeah, does that make sense to you guys?
Yes.
Okay, sweet, thanks. And you guys can turn your mics on if you want to talk. I'm just not going to see your faces. Or you can also use the chat function if you want to. Okay, so we know M. We know the rate, which was given to us as 0.7%, which is 0.007. Be careful, you have an extra zero because it's 0.7%, not 7%. Time is 5 years, so 5. And N, it doesn't tell us N explicitly, so we assume N to be monthly, so 12. Right, the one variable that I don't know is the P variable, so that's the one I'm going to use to solve for. That's the formula I'm going to use. All right, let's just plug things in now. That's 150. Parentheses, 1 minus 1 plus 0.007 divided by 12 to the parentheses negative 12 times 5. Close it. Close the numerator, divide by the denominator. 0.007 over 12. Okay, and you get 8,841. So here it is right here. And 79 cents to the nearest cent. Did you guys get that? Okay, still typing?
Still typing.
Okay. Okay, while you guys are finishing that up, let's just let me just answer an extra question. So this is the amount that we figured out was the present value, right? In other words, this is the loan amount that you took or that you're capable of taking, assuming that you can make $150 monthly payments. So that kind of tells you, like, let's say you're buying a car or something. If you can afford $150 at this current rate, well, this is a very small rate, but let's suppose you have this rate, then that means that you can afford to take a loan of $8,841 so that you can afford a car that costs this amount. But in terms of how much do you actually pay, you pay $150, right? 12 times a year for 5 years. So altogether you paid $9,000. You pay $9,000 spread out over that time period in order to take a $8,841 loan. Yeah. So you pay a little extra to get this cash up front, right? You get this $8,841 right up front, and you pay $9,000 in the long haul. So how much did you end up paying in interest? Just $158. So this is actually not too bad in terms of the proportion. 158.21 divided by the loan amount. That's, what is that? 1.7%, right? That's just because our rate was so low, 0.7%. 0.7% was really good. But later on, we'll see what happens with the typical interest rate. All right, any questions for number one, guys? Is that okay?
That seems okay to me.
Okay, sweet.
That's good.
Sweet, sweet. Okay, let's go to number two then. It says evaluate the amortization formula. If this time P is 21,000, let's see, R is 5.27%. M, we're not given. 5.27% means 0.0527, right? T is equal to 5 years. I think I took this number from, I'm thinking about a car loan, so average car interest rate. Yeah, this is what I took that number from. So the average US auto loan interest rate is 5.27%. That's where this came from. So this is an actual like situation, right? You're gonna buy a car, your car costs $21,000. Or at least that's how much you're gonna finance. So let's say maybe you made a down payment and this is the remainder that you have to pay. 5 years is a typical period. They usually say it as 60 months, but it's the same thing, 5 years. And so you wanna know what is your monthly payment gonna be. Right, so this time we're using the monthly payment formula, right? This one on the bottom, M is equal to P times R over N. Oops, sorry, mistake here. And bottom parentheses for the bottom, 1 minus parentheses 1 plus R over N to the parentheses negative NT. Close, close. Yeah. Again, if you're doing in decimals, you don't have to worry as much about these parentheses, but if you're doing it on a calculator, then you most definitely do. All right, I already filled out all the information here, yeah? 21,000, M is the thing I don't know. That's why I know I need to use this formula to solve for M, right? So I'll just plug in the values. 21,000, 0.0527 divided by 12 and divided by 1 minus 1 plus 0.0527 divided by 12. Oops. Exponent, parentheses, negative n, which is 12, times t, which is 5. And you should get 398 to the nearest cent, 90 cents. So 398, 90 cents. Okay, anybody not get that? So if you did not get that, then just unmute your microphone, let me know, or send me a chat. You can chat either to the group or you can chat also directly to me.
Hi, Justin.
Yes.
Hi, can I ask why you did negative 12?
Oh yeah, that's because the exponent
Well,
is.
that's part of the formula too. That's just part of it.
Yeah, it's part of the formula. We're using the M one right here, this right here. Yeah. In both instances, the exponent is negative. A negative exponent doesn't actually mean your number is going to be negative. It means it's 1 over nt to the positive power. Yeah, 1 over nt positive. Negative exponent just means you flip it over to make it reciprocal. Right. Did you guys get this? 398.90.
Got it.
Okay, sweet. So that is this is using the actual current average car financing, yeah, like auto financing rate for the US. So you can expect something roughly similar if you're to go and buy a car and finance it. Now, what does that mean in terms of how much you actually pay? Let's look into that a little bit. So 398.90, that's how much you pay per month, right? So 12 times per month for 5 years. So overall, you pay $23,934. And that is for a car, or you're taking a loan of $21,000, which means $2,934 was paid in interest. So you paid an extra $2,934. If you consider that as a fraction of how much money you got up front as a loan, that is roughly 14%, yeah? So dividing that interest by the amount of the loan itself, you paid roughly 14% overall. This is if you have a 5.27% interest rate.
Okay.
Yeah. And just to remind you, well, what if it was simple add-on interest? So simple add-on interest would have been the 21,000, right? Times the interest, 0.0527, times the number of years, which would have come out to 5,533. So that would have been a lot worse if you have simple add-on interest. 5,533.5 divided by 21,000 is 26%, as opposed to about 14%. That was add-on interest was from a previous section. I think it was the second section we did. Simple add-on interest. Okay, so just extra stuff. The actual answer to the question was just that first number we got, the 398.90. That one. This guy. All right, guys, number 3. Number 3 of 5. Find the monthly payment for the loan. You're buying a $395,000 condominium with 15% down payment, financed for 30 years. All right, so first of all, I know it's telling me to find the monthly payment. Right here, it's telling you which one you're going to use. The second, there's two tip-offs. First tip-off is it tells you to find the monthly payment. So right away, I know this is the formula I'm using. But the other tip-off is that it tells you the cost of the house, right? So you know the cost of the house, meaning you're going to be able to figure out what your P is. And so since you're going to find P, you're going to be given P. I'm not going to solve for P. I'm going to solve for M. That's the one I don't know. Okay, however, guys, there is a little stipulation here. There's a little bit of extra work that you need to do to find P. P is not 395,000. This is not P. Because you're making a 15% down payment, right? So this is what typically would happen. If you're going to buy a house, you start with a down payment, and then you finance the rest, right? So you borrow the remainder from the bank. So what that means is you have the 395,000. You got to multiply that by 0.15. That tells you you're making a down payment off the bat of $59,000 and $59,250. So how much are you borrowing? What is the P? It's the total cost of the house subtracted what you made as a down payment. So minus the $59,250. Which gives us our P is $335,750. All right, up to that point, is that okay with you guys? Do you have any questions how I got this?
No.
Okay.
Could you explain one more, please?
Oh yeah, sure. So I'll look at number 3. It says this is the cost of the house, $395, right? And you're making a 15% down payment. So all I do is just multiply by 15%, 0.15, to find out how much that down payment actually is. Then once you have the down payment, I just subtract it from the total. Does that make sense, Chitai?
Yes.
Okay, great, thank you. So this is the remainder that I have to borrow from the bank, in other words, right? I had this money in my pocket. I paid that up front, and then this is what I have to finance from the bank. So that's how much you're gonna borrow. That's your P value. M, we don't know. That's why we're gonna use the formula to solve for M. The rate is 3.345%. Okay, so that as a decimal is 0.03345. By the way, this is the actual average interest rate for the US, I think. I don't know, you looked this up a moment ago. Average mortgage rates. Let's see. Oh, this is a different number it's giving me. This is because let's see. What did I look up before? Oh, this is telling me 3.32%. According to a survey. Okay, so we're a little off here. I found this value somewhere else. I don't remember where I looked it up, but it's kind of similar, right? 3.32 or 3.345, pretty similar. Let's just stick to this one in case you started already. All right, so that's our rate. Time is 30 years. That's a typical length of a mortgage, 30 years. Usually 15 years or 30 years. And N is not said specifically. No, actually it is said specifically. It said monthly payments. So monthly payments means 12. And it says find the monthly payment. So we're using, again, the same formula, yeah, the M1. I have all my values. I'm just going to plug them in now. So 335,750 times 0.03345 divided by 12. That's the numerator. The denominator is 1 minus parentheses 1 plus 0.03345 over 12, close parentheses to the parentheses negative 12 times 30. And we see our monthly payment is $1,478.77 to the nearest cent right here. Now, if you're plugging this into a calculator that's like a regular standard phone calculator or something like a handheld scientific calculator, this is what you want to type in: 335,750 times parentheses 0.03345 divided by 12, close the parentheses, and then divide. You notice I didn't put my numerator in parentheses. I didn't need to because order of operations is gonna be correct anyway. But for the denominator, you definitely need it because you've got this minus there. So you're gonna do parentheses for the denominator, 1 minus parentheses 1 plus 0.03345 divided by 12, close, and then exponent button, new parentheses, negative button, 12 times 30, close that exponent, and then close the denominator. Hit enter. So that's what you would type in. Did you guys all get this? 14.
Yeah.
Okay, sweet.
Okay.
Really fast.
What was that? Sorry?
I'm actually really like, I'm happy that we're learning about this that actually like pertains to our lives. Like our future, it's like actually good for us. So that's awesome.
Oh, okay, right on. I thought you had a question, but comment. That's great. Thank you. I appreciate that. Okay, so let's answer like a follow-up question though. So that's your monthly payment, right? Let's see how much you actually paid. So 1,478.77. You pay that 12 times a year, right? It's times 12 in 1 year. It means you pay 17,745 in 1 year. And you carry that out for 30 years. So altogether you paid $532,000. Yeah, roughly that. 532,357. That's your total payments. Now, how much was interest then? So 532,357.20. If you subtract how much you got as a loan, this is the amount you got as a loan, right? The bank gave you this amount. This is how much you paid in the end. So that means you paid an extra $196,000. Okay, as a fraction of the loan amount that they gave you, that means 58.6% roughly. So almost 60% is extra that you paid. You almost paid 60% of the loan amount itself in interest. It's kind of depressing, but I mean, that's that's just how it is. This is what the standard interest rate today. Yeah.
Pretty crazy.
Yeah, right. So it's, I don't know, it's kind of good to know at least. I mean, you know, in the end, it might not be avoidable. Like you might end up doing that, but I think like I have a mortgage for 30 years, but you know, at least you know, and you can kind of make your decisions based on like what you're able to afford. Later on, at the end of the questions, we'll look at what happens if you do 15 years instead of 30 years. Okay, so that's number 3. Number 4, this is just more of a standard question. We have a couple of differences. M is 650, N is quarterly now. So that means you're only paying 4 times in a year or every 3 months. We're using a rate of 3% and T is 10 years. So find the present value. In other words, you know the monthly payments that you can make. How big of a loan can you afford then? Oh, sorry, not monthly payments. You know the quarterly payments you can make. So how big of a loan can you take out? Maybe you get a good interest rate on your car, right? And you want to figure out what you do. Okay, so let's do this. We're using the P formula this time, right? Because we have the M. Oh, this is what I like to do. I like to start by just writing what I have and what I'm missing, and then that'll tell me which formula to use. So I know the monthly payment is $650, so I'm obviously not going to use the formula to solve for that. The rate is 2%, so 0.03. Time is 10 years, and N is quarterly, so quarterly means 4 this time. And then P is the one missing, so I'm going to use this formula for P. All right, let's plug the thing in. It's going to be 650 times 1 minus parentheses 1 plus 0.03 divided by 4. Exponent negative 12 times, oh, sorry, no, 4 times 10, right? And the bottom, it's 0.03 divided by 4 again. So you see we end up with 22,390 and 51 cents. It's making quarterly payments of 650. So if you want to think about that monthly, that's about $217 per month, roughly. Just paid quarterly. All right, why don't we do the same thing as a follow-up question? How much do you actually pay? you pay that $650, right, for 4 times a year times 10 years. So altogether you pay $26,000. $26,000, but you the loan amount that you got, how much they gave you. Let's say you took that from a bank. This is only the $22,390.51, which means that $36,000 or $3,609 was paid in interest. That's extra that you paid. And in terms of the loan amount itself, that means about 16% was paid in interest. Yeah, you paid about 16% interest. It's making sense to you guys?
Yes.
Can you scroll up a little bit on that question?
Oh, here? Or here?
Yeah, a little bit more. Oh, no, on the calculator.
Oh, calculator. Oh, yeah. Let me just shrink this down a little bit.
Thank you.
Sure. All right. Ready for the last one, guys? Okay, don't all chime in at once.
Ready for
Okay. Thank you. I'll take your general silence as acceptance that we move forward. All right. So last question. Find the monthly payment. Find the monthly payment. Okay, so I actually looked up the average single family cost in Honolulu, which is $835. Crazy. Super expensive.
Yeah, that's big.
That's Honolulu though. So I guess if you want to live in the city, and you want to buy a house, then that's what you got to deal with. But this is this is not average. It's actually the median price.
Okay.
Yeah. So remember, median is what you get if you put that if you line things up, you look at the middle number, right? So that's the median price. Which means there are going to be things that are cheaper for sure, and that's in Honolulu. So if you move outside of Honolulu, it's also cheaper. So. Okay, anyway, it's still expensive. It's so crazy. Like Hawaii is just getting nuts, but what can you say? What can you do? It's the price you pay for being able to surf every day. Okay, $835,000 home, 20% down payment means this is how much you're gonna pay up front, similar to the previous question where we did 15% down payment. And the remainder is gonna be financed for 30 years. Okay, this interest rate I took from the average interest rates in Hawaii, I think it was. Wait, where did I get this from? I forget. This looks a little different. Maybe it's Honolulu. What the? This is okay. I don't know what happened. Let's change to these values. Is this Hawaii? Yeah, this is Hawaii mortgage interest rate. Okay, well, it's lower. I don't know. Like I looked this up half an hour ago. It was different, but anyways, like maybe I typed something wrong. So we're gonna use 3.00% for 30 years because that's this one right here, right? And we'll use 2.47% for the 15 years. On your homework question, they're the same both times, but for us, let's do it in a real life situation. The mortgage rate you get for 15 years is actually better. So let's use that. These answers are going to change. So I'm going to erase this, erase all this. I have new values now. Let's see if we can do this. All right, I'll give you guys some time to think about it, and then we'll walk through it together. So see if you can figure out before I tell you. All right, guys, let's start talking about this together. So, first of all, I'm asked to find the monthly payment. So clearly I'm going to use the monthly payment formula, this guy, right? And I'm given basically the P, except it's kind of like that last one. I don't have the actual P. I have 835,000, the cost of the house instead, right? Let me just clear out the calculator before I start. Clear all the old stuff. Yeah. Oh, I should have left that one. Okay. No, it's blank spots. Okay. All right, so it's taking an inordinate amount of time for me just to delete my previous entries. Okay, so we have P, but not exactly. We have $835,000. We make a 20% down payment, so times 0.20, right? And that means the remainder I'm financing from the bank. So 835,000 minus the 167,000 gives me 668,000. This is how much I'm actually borrowing. All right, the M value. Oh, sorry, what? Question?
Can you make the calculator screen bigger, a little bit bigger?
Oh, yeah, yeah. Is
Thank you.
that better?
Yes.
Okay. So 668,000, that's the amount I'm actually borrowing. The monthly thing is what I'm trying to figure out, right? So I don't know that. I know, what else do I know? I know the rate, 0.0300, so I don't need that. I know the time for 30 years, and I know N is 12 monthly payments, yeah. Okay, so I'm ready to plug those values in. It's gonna be 668,000, 0.03 divided by 12 on the top, and then the bottom, 1 minus 1 plus 0.03 divided by 12 to the parentheses negative 12 times 30. Did you guys get this?
This is for part A, yeah?
Yeah, for part A.
Okay.
So I'm going to answer it like this, 2816.31. Okay, even though I'm writing this, for the homework, be careful because I think they prefer that you keep the entire thing in your calculation to the end. So actually, you know, when I was testing out, I did it both ways and both answers came out correct for me. So I don't know if it will matter or not, but I know for sure if you keep this entire thing, it's going to work. I think it makes more sense to use the cents. So I'm just going to do it like that. And like I said, I think either one worked for me when I plugged in two different values. I think there's some leeway with the rounding and stuff. All right, anyway, so that's the monthly payment, right? That's the answer to part A. Now you want to know how much you're going to save if you finance for 15 years instead. If you finance for 15 years, you get a lower interest rate. So what changes? Okay, let's look. T changes to 15 for one thing, right? And the rate also changes to 0.0247 now. The amount borrowed is still the same. The monthly is still the same. So I'm just going to adjust things a little bit. Instead of 0.03, I'm going to put 0.0247 in both of these rate spots. And instead of 30, I'm going to change that to 15. Yeah, okay. Did you guys get this?
Yes.
Okay,
Yes.
sweet. 4,444 and 72. Okay, sounds kind of bad, right? I mean, Nick, yeah, it is. It is a lot for a monthly payment, and I mean, this is a really expensive house, but yeah, let's see what happens though. Let's see what happens. So for option A, for paying 30 years, how much do you pay in total? You pay 2816.31. You do that 12 times a year, right? So times 12. And for 30 years, so times 30, times 12 times 30. So in the end, you pay 1,013,871.60 cents.
I have a question.
Yes, question.
Wait, did you change that percentage from the 3%?
Yes.
You
'Cause
changed it.
Yeah, because part B it says for 2.47%.
Oh, I see. Okay,
Yeah.
sorry.
No worries. And I just do that based on this.
Okay.
Average rates, mortgages in Hawaii, 3% for 30 years and 2.47 for. This is last week's rate, I guess. Which I don't know again why it changed from what I looked up earlier, but whatever. Okay, so this is how much you end up paying, right? 1,013,871 if you go with the 30-year option. What happens if you go with the 15-year option? So you go 4444 72 12 times a year for 15 years this time, right? That means you end up paying $800,049.60. So how much is saved? You take the 30-year option, 1,013,871.60, and you subtract the 15-year option, 800,049.60. Oh, they both happen to end with 60. That's kind of just lucky. And so the end result comes out to $213,882 that you saved. To the nearest dollar. Actually, in this case, it just so happens that I ended up with no cents. So this is to the nearest dollar already, but normally you'd have to round to the nearest dollar. Does that make sense to you guys?
Yes.
Okay.
Yeah.
So, I mean, this kind of looks good in a way, right? You save $213,000 by paying off in 15 years rather than 30. So you see the benefit of shortening the length of the loan. And even if you had kept this as the same interest rate as 3%, this still would have played out. You still would have saved a lot of money. In fact, let me just show you real quick. If this had been the same interest rate, supposing, okay, pay a little more, but 4613.09. You still end up paying 830,000 as opposed to 1,013,000, right? So you still save money with the same interest rate. The difference is the period of the loan. So if you pay it over a shorter period, then you end up saving a lot of money. That being said, of course, this is good for you to know to make your decisions, but you may have a reason for doing 30 years instead, because like maybe you can't afford this monthly payment, but you want a house that costs this much. So you got to go with the 30 years. I have a 30-year right now. And then the other thing is that if you take the amount that you save per month, and let's say you invest that somewhere else, let's see, 444, 4.72, right? Minus 2816.31, which means there's an extra $1,628. Now let's say I invest that instead and see what will happen at the end of 30 years. So why don't we use the annuity formula? Let me just remind you what that is. This is from the previous section. Right, this is the future value for an annuity. We're going to use 1628, the amount that you save per month, 1 plus, and let's say you have a rate of, conservatively speaking, I get 5.1, like pretty safely. And let's just say monthly for the same period of, oh, actually, this is kind of tricky because I'm saving that for, what is that? This is say 15 years because I'm only gonna do it for the duration of the shorter loan. -1, okay, divided by 0.051 divided by 12. All right, so let's say instead of for the 15-year period, instead of using the 15-year mortgage option, that I take that money I save and I invest it at 5.1%. At the end of those 15 years, I end up with $438,000, right? So that might be a reason to go with the 30-year loan instead, because if I take that savings per month and I invest it instead, then you'll see you end up with positive 438,000 as opposed to saving, how much was it? As opposed to saving 213,000, right? So it might make sense for that reason. You don't even have to invest the entire amount. You could maybe just take 1,000 of it, and you'd still make out better in the end, right? And you can decide what you want to do with that extra $600. You maybe just buy groceries or something.
Craziness.
Yeah, crazy, huh?
$600 worth of groceries. That's a lot.
I don't know. I spend more on that per month, I think, than groceries so expensive, man. Okay, guys, that's it. Any questions about anything? If you want to, you can try out some homework questions and see if it works for you. You can ask me questions while I'm here. You can just try it out yourself. It's basically the same thing we've been doing. The last question is just like their number 5, except it doesn't break it into steps, so you kind of just gotta do it yourself.
So I guess I'm on the homework online, and I'm on
Yeah.
number 5. Find the monthly payment for the loan. Round your
Right.
nearest
Two.
Uh-huh. This one.
And so that is the equation finding P, or I mean, I'm sorry, finding M.
Right. So here our
So
P is 12,850, right?
let's see.
The rate is 2.8%, so 0.028. Time is 30 months, means 30 months divided by 12 months in a year is 2.5 years. So T is 2.5. Yeah. And monthly payment for N is 12.
So instead of 30, it's 2.5.
Right, because it's months. T is always in years.
Okay, so it's 2.5, 2.5. Oh, that might be.
Ew. Let's see. 12,850. 0.28. 28.
Yep. All right.
Yeah, worked. Okay. Sweet. So yeah, I got 443.99. Nearest cent, that actually rounds up to 4. Zero. Let's check. Did I do that
So
right?
then how much? Okay. That was.
Yes,
that.
I'm correct. Check mark is so satisfying.
This one.
Okay.
Okay.
Good. Yeah.
Yeah, okay. Shoots.
Thank you.
No problem. I guess see you guys next time, huh?
Bye.
Thank you.
Thank you.
Thank you.
Bye.
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 This will be posted to the YouTube later, yeah?
Yeah, I'm
review?
gonna post this one.
Okay.
So your guys' class will be the
Professor,
posting
that's
today.
it.
Bye. Chisai, thank you.
I have a question.
Oh, question. Oh, yeah. Sorry, I thought you said something else.
I don't understand about nearest sense. The last times
Okay.
homework, I think
This one
nearest
over here.
is 2 decimal.
Right.
But the last times homework number 6, the nearest sense is just 1 decimal.
Oh, really?
Yeah, and
The previous homework.
previous homework.
Okay,
11,
let me take a look.
5.
Yeah, I'm gonna stop this video first because that's not pertinent.